Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions in the chapter properties of matter. So any doubts if you have any mistakes, then please write that in the comments. We shall obviously clarify them in the subsequent videos. Also, please install our Sapience Education application where we shall upload some important uh, questions which shall be obviously helpful in your revision. So here it is told that spherical soap bubble of radius 3 centimeters found inside another spherical soap bubble of radius. So let's consider smaller. So the outer radius is 6 centimeters. The internal pressure of the smaller bubble of radius 3 centimeters, the above system, equal to the internal pressure of another single soap bubble of radius r centimeter. So let's call this as R1. The value of R is. Let's suppose the outside pressure is P naught, which is the atmospheric pressure. So now the pressure here, it's called this as P2, which is the pressure inside the larger the bubble. So that will be P2 minus P naught, that is equal to 4T by uh, 4T by or 4S by R. 4 is by R, which is 6 centimeter. 4 is by R, I can say. But S is the surface tension. S is the surface tension. And so the pressure, the internal pressure of the smaller bubble, that will be, let's call this as P. And it is told that the internal pressure of the smaller bubble is same as the internal pressure of this single bubble. So let's call this as P also. So therefore, we can say that P minus P2, that will be equal to 4S by R1. From here, P2 is equal to P2 P naught plus 4S by R. So therefore, P that would be equal to P2 plus 4S by R1, which is equal to P naught plus 4S by R1 plus 4S by R. And that will be also same as this will be P minus P naught, that is equal to 4S by R. So that is same as P naught plus 4S by R. Therefore, R value we have to find out. So therefore, if we equate these two, then we get 4S by R, that is equal to 4S by R1 plus 4S by R. Now 4S we can take as common and we can cancel out. We can say 1 by R, that is equal to 1 by R1, which is 3 centimeter, plus 1 by 6 centimeter. So this will be 2 by 6. So 1 by R, that is equal to 6, 3 to the 6 plus 1, so 3 by 6, so 3 on 6, 3 on 6. So R is 2 centimeter. R will be 2 centimeters. So the value of R is 2. 2 is the answer. The grade is told a square aluminum whose sphere modulus is 25. A square aluminum sphere modulus is 25 into 10 power 9 become the square. So square aluminium is there. Shear modulus is G. That is 25 into 10 power 9 Newton per meter square. Slab, so square millimeter slab of side. The side is 60 centimeter. The thickness is 15 centimeter. Is subjected to a shearing force. Here one shearing force is applied on its narrow face. It is a square. Side length is 60 centimeter. Thickness is 15. It is subjected to a shearing force on its narrow face, which is 18 into 10 power 4 Newton. The lower edge is inverted to the floor, means the lower side is fixed with the floor. The displacement of the upper edge is. So it will get displayed by a length x. So then we know that the shear modulus that is given as is force by area by x by n, which is same as tan phi. So this will be F L by AX. So the displacement as mass, which is x, so x will be equal to F by AG. So force that is given as 18 into 10 power 4 Newton divided by is into L. The side length that is 60 centimeter, which is 0.6 meter, 0.6 meter. Area that is 0.6 into 0.15 to G is 25 into 10 power 9. So this will come in meters, so we have to convert this into micrometer. So this will be 0.6 and 0.6 will get cancelled. So is 3 5 15, 3 6 18. This is 6 by 5 by 100. This is again 25 to 10 power minus 5 meter. This is 25 4 100. This is 6 4 24. 24 by 5, that is 4.8 to 10 power minus 5 meter, or I can say 48 into 10 power minus 6 meter. So it is 48 micrometer. So 48 micrometer is the displacement of the upper edge of the square slab. So 48 is the answer. And it is told a uniform heavy rod. Uniform heavy rod is there, it is of mass 20 kg, and the area of cross section that is 0.4 meter square, 0.4 meter square, and the length that is 20 meter is hanging. So this is hanging from a fixed support. uniform heavy rod of mass 20 kg is hanging when this 20-meter height of fixed support, neglecting the lateral contraction, the elongation in the rod due to its own weight is, so here mg will act. Mg is the force acting its own weight. Value of x is, so let's say the elongation in the rod, that is delta L. So delta L is x into 10 power minus 9 meters. That x value you have to find out. Is given that the Young's modulus is 2 into 10 power 11 meter per meter square, and value of g is 10 meter per second square. So therefore, I will say that f is equal to y a by l into delta L. Therefore, delta L will be equal to f l by y a. So force is equal to mg into l by y a. So therefore, the extension, that is x into 10 power minus 9, that is equal to m, mass is 20 kg into g, that is 10, to L, that is 20 centimeter, and by Young's modulus, which is 2 into 10 power 11 into area of cross section, that is 0.4 meter square. This will be 2 times 20, 4, 5, 10, 900. 4, 5, 20. So this is 5 into 10 into 10 into 10. Thousand. 5 into 10 power 3 into 10 power minus 11. So this will be 5 into 10 power minus 8, or I can say 15 into 10 power minus 9. So it means therefore the value of x will be 50. So 50 is 1. And here it is told in an experiment to determine the Young's modulus of a wire and length exactly 1 meter. The extension in the length of the wire is measured as 0.4 millimeter with an uncertainty of plus minus 0.02 millimeter when a load of 1 kg is applied. The diameter of the wire is measured as 0.4 millimeter with an uncertainty of 0.0001 millimeter. The error in the measurement of Young's modulus is found to be x into 10 power 10 meter per meter square. The value of x is. Therefore, we know that Young's modulus, which is f by a by delta L by L. Now, this extension we can take it as x over. I can write fl by a delta L, or I can write fl by ax. Suppose fl by ax, where x is the extension, x is given as delta. Now, here it is told the error in the measurement of y that is equal to x into 10 power 10 into per meter square, then x value I have to find out. So let's call this extension as y suppose, since here x has been already used. So now the length of the wire, that is given as 1 meter, and the error in the length, that is delta L, that is equal to this delta L is not same as this delta L. This I can call it as small delta L. This is the extension by this small delta L, where delta L is, you're saying it is the extension in program. So, and this delta L is the error, the absolute error in the measurement of the length of the wire. And that value is 0. Essentially the wire, the diameter. Okay, so it means here the length of the wire is exactly 1 meter. So there is no error. So we can keep this as delta L only. Delta L is like, but this is why you are saying that is delta L, which is the extension. So it means error in the measurement of L, that is 0 only, since it is told the length is exactly 1 meter, and the extension, which is y, that is 0.4 millimeter, and the answer 10, it means the absolute error in y, of the absolute error in the extension, that is delta y, that is 0.02 millimeter. 0.02 millimeter, and the load of 1 kg is applied means the load which is the force that is 1 kg. So now the force will be equal to mg, where mass is equal to 1 kg and g is 10. So I can see g is 10 meter per second square. So I can say the load, that is the force, that is 10 newton. 10 newton. And this force is fixed, it has no error. Since here the exact value of the load and the exact value of G has been told. Now the diameter, so area of cross section, I can write pi r square, or I can write pi d square by 4. So therefore, the L's modulus, I can write FL, which is mgl, mgl by a, which is pi r square into y. This would be mgl by, which is pi d square by 4 into y. Here, this is delta L. Okay. So you are saying small y, this is not capital Y. Y is the extension. That D is the diameter. So now the D, which is the diameter of the wire, that is given as 0.4 millimeters. 0.4 millimeter, and the uncertainty is the absolute error in the measurement of the absolute error in the measurement of the, that will be 0.01 millimeter. 0.01 millimeter. Now the error in the measurement of the Young's modulus that we have to find out. So now from here we can see that this 4mgl by 5, these all are constants. So now 4mgl by 5, these are constants. So hence Young's modulus, I can say it is 4mgl by 5 into 1 by d square 1. So it means the relative error in the measurement of the Young's modulus, that is delta y by y, that is equal to 2 delta d by t plus delta y by y. Since y this part is a constant. So now therefore delta y by y, that is equal to twice of the relative error in the measurement of uh, diameter of the wire, which is now delta d is 0.01 millimeter divided by d, that is 0.4 millimeter, plus which is delta y, which is the error in the measurement of the extension. Now error in the measurement of the extension in the length of the wire, that is 0.02 millimeter. So this will be 0.02 millimeter divided by 0.4 millimeter. So hence, so it will also 0.02, this will be also millimeter will get cancelled. This is equal to 2 into 0.02 by 0.4, which is, this I will cancel out. So this will be 2 to the 4 by 40, that is 1 by 10. So hence we can say, once the absolute error in the measurement of the Young's modulus, so uh, that will be this delta y by y, which is 1 by 10 into y. Now the actual Young's modulus value we have to find. So that will be y equal to 4 into 10 mass, that is 1 kg, so go into m mass, that is 1 kg, into g, that is 10, into L, the length, that is 1 meter, by 5, into d square, 0.4 millimeter to 10 power minus 3 whole square, into y, which is the extension, which is 0.4 millimeter again. This will be power 3. This y will be 40 by 5 into 40 by 5 into, this will be 4 into 10 power minus 4. So this will be 16 4 just 64. 64 into 10 power minus 4 minus 12. So this 4 times of 40, 4, 16 power 64. So this will be 10 power 13 by 16 pi. This much Newton per meter square. This will be 1 by 10 into the Young's modulus is 10 power 13 by 16 pi. This makes Newton per meter square. So this will be 10 power 10 into 1. So this will be 10 power 10 into 10 power 3 I can write. This will be 100 by 16 power into 10 power 10. 10 per meter square. So therefore, delta y, therefore delta y, that will be 100 by 16 times, that will be 4 for 16, 4 to 10 times 100. So that is 25 by 4 pi to 10 power 10 Newton per meter square. By 4 pi to 10 power 10 Newton per meter square. So 25 divided by 4 pi, so that will be approximately 2, I can say. Since right, 24 pi, 4 pi is, which is a 12 approx, and 25 I can take approximately 24, so it will be 2, approximately 2. So it is approximately 2 into 10 power 10 Newton per meter square. So it means the value of h should be 2. So 2 is the answer. But here it is told a wire of length L and radius R is clamped rigidly at one end. So it is clamped rigidly at one end. So of length L and radius is R. When the other end of the wire is pulled by a force F, its length increases by 5 centimeters. So here the increase in the length, that is delta L, that is 5 centimeter. Increased by 5 centimeter. Then another wire of the same material, same material is there, is of length 4L and radius is 4R. It's pulled by a force 4F under same conditions. The increase in the length of the wire here, delta L dash, that will be how much? So the Young's modulus will be the same, since it is told that another wire of the same material has been used. So the Young's modulus will be the same. So you can say y will be equal to FL by A delta L. FL by A delta L. So now delta L, that we can say delta L is FL by AY. For the first wire, the area of cross section, that is pi r square. And for the second wire, the area of cross section A dash, that is pi into 4R whole square. And similarly, L dash, that is Therefore, delta L dash. Now delta L, therefore delta L that will be FL by F into L by A, which is pi r square into Y. And so delta L dash that will be equal to 4F to 4L divided by this will be 16 pi r square, 16 pi r square into Y. 4 for just 16, so we cancel, so which is also Fl by pi r square into Y, which is same as delta L. So here it is told its length increases by 5 centimeters. So here delta L is 5 centimeters. So the increase in the length of the other wire having 4 times the length. That will be also delta L only, which is 5 centimeters. So the increase in the length of this wire will be also 5 centimeters. So 5 is the answer. Here it is told the excess pressure inside a liquid drop, that is P minus P naught. Outside we have atmospheric pressure. Inside the pressure is supposed to be then P minus P naught, that is told 500 Newton per meter square, and that is equal to 4 S by R, where S is the surface tension of the liquid drop. This is the surface tension, and R is the radius of the drop. R is the radius of the drop. It has been told that it is 2 millimeter, so it is 2 10 power minus 3 meter. The surface tension S of the liquid, that is x into 10 power minus 3 Newton per meter. So now 500, that is equal to 4 into S, is x into 10 power minus 3 by R, is 2 into 10 power minus 3. So 10 power minus 3 will get cancelled, 2 to the 4. So now x will be equal to 250. So the value of x will be 250. Here has been told that a small spherical ball of radius 0.1 millimeter, it means it is 10 power minus 4 meter, and density rho, that is 10 power 4 kg per meter cube, falls freely under gravity through a distance h before entering a tank. So it will fall down through a height h before entering a tank. So it will enter a tank of water. After entering the water, the velocity of the ball does not change. Means here the final velocity will not change. So it will be the terminal velocity also. It continues to fall with same constant velocity inside water, then the value of h will be. So this v only, that is equal to 2r square into rho minus sigma into g by 9 eta with the terminal velocity, and v also, that will be equal to root over 2gh. Since by v square will be equal to u square, u is 0 plus 2gh, so that is v will be equal to root 2gh. So therefore root 2gh, that is equal to 2r square into rho minus sigma g by 9 eta, where eta is the coefficient of viscosity of water, and r is the radius of the spherical ball, and rho is the density of the spherical ball, but sigma is the density of water. Sigma will be 10 power 3 kg per meter cube, and g will be 10. So therefore we can say root over 2gh, 2 into 10 into h. So the value of h we have to find out. Root 2gh, that is equal to 2 into r square, that is 10 power minus 4 whole square, into 10 power 4 minus 10 power 3 into g, that is 10, divided by 9 eta. Eta is 10 power minus 5. Therefore, we can say root over 20h, that is equal to 2 into 10 power minus 8 into 10 into 10 power 3 into 9. Since by 10 power 3 I can take as common from here, then 10 minus 1, that is 9. Then divided by 9 into 10 power minus 5. So 10 power minus 5. So now 9 and 9 will get cancelled. So therefore we can say 20 root over 20 means 2 root 5. So 2 into root 5 is, that is equal to 2 into 10 power 4 plus 5 minus 8. So it will be, so 2 and 2 I can cancel. So root 5h, that is equal to 10 power 1. So it means 5h, that is equal to 100. We can square both sides. Then h will be equal to 20. So from 20 meter it will fall down. So continues to fall with same constant velocity inside water, then the value of h will be 20 meters. Here it is told a liquid of density, liquid is there of density 750 kg per meter cube, flows smoothly through a horizontal pipe. So it flows through a horizontal pipe that tapers in cross section. The cross section area gradually decreases A1, which is 1.2 into 10 power minus 2 meter square, to A2, which is equal to A1 by 2, means it is 0.6 into 10 power minus 2 meter square. Then the density of the liquid, that is 750 kg per meter cube. The pressure difference between the wide and the narrow sections of the pipe is 4,500 Pascal. The rate of flow of the liquid is. So the pressure difference, that is 4,500 Pascal, or I can say 4,500 or 4.5 into 10 power 3 Newton per meter square. And the rate of flow of the liquid is dash into 10 power minus 3 meter cube per second. So the answer will be how much? So as we know, by the Poisson's equation, so according to the Poisson's equation, we can say that the volume flow rate, which means that delta V by delta T, that where V is the volume here. So that is pi delta P into R power 4 by 8 eta L. Now, we have to find the, we can find the, so according to the equation of continuity, we can say that A1 V1, that is equal to A2 V2 if the speed of flow of the liquid at the area of cross section A1 is V1, and at the area of cross section A2 the velocity of the fluid flow, that is V2. So then A1 V1 will be equal to A2 into V2. Here we are using the equation of continuity. Now A1 V1 is also same as the rate of flow, means the volume flow rate of the liquid. Volume flow rate of the liquid. Since why? If we do d by dt of the volume, which is A into X, then A into V only will come. So area of cross section into velocity, that is only called as the volume flow rate. Now here the pipe is horizontal, so it means the height is same only. So therefore we can say P plus rho GH is P1 plus rho GH1 plus half rho V1 square, that is equal to P2 plus rho GH2 plus half rho V2 square. But here H1 and H2 it will be same only, since both the ends are at the same height, since it is told that the pipe is a horizontal pipe. So these two I can cancel. So the pressure difference, which is P2 minus P1. So here the velocity is high, the area will be less, so the velocity will be high, since area into velocity is constant. So when the velocity is high, the pressure will be low. So P2 is obviously less than P1. Since by here the area is high, so the velocity is low. So the pressure is high. So P1 is more than P2. So I can say P1 minus P2, that will be equal to half rho into V2 square minus V1 square. So this P1 minus P2 value, that is only given as the pressure difference in between the wide and the narrow sections, which is 4.5 into 10 power 3. Therefore, I can say 4.5 into 10 power 3, that is equal to half into rho. Rho is the density, which is 750 into V2 square. Now from here, V2 I can say, so since P1 and A1, here actually what is happening, A1 is more than A2. So V1 will be less than V2. So V2 is higher. So we can find V2 in terms of P1. Therefore, V2, that will be equal to A1 by A2 into V1. So this will be A1 square by A2 square into V1 square minus V1 square. So then we'll get about 4.5 into 10 power 3. That is equal to 1 by 2 into 750 into this will be V1 square I can take as common, and A1 by A2 whole square minus 1. Now A1 by A2, that will be obviously equal to 2. Since A2 is A1 by 2, so A1 by 2 will be equal to 2. So therefore we can say this 2 I can take it here. So 2 into 4.5 is 9. 9 into 10 power 3, that is equal to 750 into V1 square into this will be 2 square minus 1. It's 4 minus 1, that is 3. So 3 3 is 9. So V1 square will be 3000 divided by 750. So these two will get cancelled. Then 25 3s are okay. 325 is 75. And 300 is 300. So therefore V1 square will be equal to 25 4 is 100. So V1 square is 4. Therefore V1 will be equal to 2. Therefore, V1 will be equal to 2. So therefore, the volume flow rate, therefore the rate of flow of the liquid, that will be equal to A1. Okay. Rate of flow of the liquid, rate of flow, that will be equal to A1 into V1. So A1, that is 1.2 into 10 power minus 2 meter square into this is V1 in meter per second. So it is 2. This much will come in meter cube per second. So which will be equal to 2.4 into 10 power minus 2, or I can say 24 into 10 power minus 3 meter cube per second. So it means the answer is 24. 24 is the answer. Then the area of cross section of a large tank is 0.5 meter square. It has a, so its area of cross section area A1, that is 0.5 meter square, and it has a narrow opening near the bottom, having here having area of cross section A2, that is 1 centimeter square, which is 10 power minus 4 meter square. A load of 25 kg is applied on the water at the top in the tank. So here one piston, one large piston has been kept, and here the load that is kept, load that is 25 kg. Then neglecting the speed of water in the tank, the velocity of the water coming out of the opening, the velocity with which P2, with which the water coming out from the opening at the time when the height of the water level in the tank, that is set, that is 40 centimeter above the bottom, will be dash centimeter per second. So the speed of water in the tank, we have to neglect it, means V1 will be approximately 0 only, since why V1 will be much less as compared to P2. Since why obviously A2 is much less than A1. So the speed at which water will flow in the tank, that is negligible as compared to the velocity with which water will come out through the opening of the tank. So here we can apply equation of continuity, which is A1 V1 equal to A2 V2. From here we can find out V2 also, but the thing is here a load of 25 kg has been placed. So the pressure outside is P naught. So here we can say P, this level we can take height as 0 only for the opening. The height of the opening from the ground level, we can take it as approximately uh, nearly 0 only. So then, so this V2 only we have to find out. Now we can use P naught plus here pressure, which will be mg by A plus rho gh P plus rho gh plus half rho V1 square, that is equal to, here also P naught will act, the uh, atmospheric pressure which is outside. So the atmospheric pressure outside, let's say that is P naught. So P naught plus half rho V2 square plus rho g into H, that is 0. So P naught and P naught will get cancelled. We can say that And V1 that we can say that is A2 V2 by A1 also. So V1, as you can see, A2, which is 10 power minus 4 divided by 0.5 into V2. V2 to find out. So this is 5 by 10. So this is 2 into 10 power minus 4 times V2. So obviously we can neglect it. So V1 square, that will be approximately 4 into 10 power minus 8 times of V2 square. So V1 square we can uh, neglect as compared to V2. So this is approximately this is V1 only. So therefore this I can say then M is 25 kg into G, that is 10 divided by A, area that is 0.5 meter square plus rho GH. Rho is rho is so that is the density of water plus 10 power 3 into 10 into H, that is 40 centimeters, so 0.4, that is equal to half into rho 10 power 3 into V2 square. Therefore this is 5 by 10, so 5 is 25, so this will be 500 plus this 400, so this is 4 0.4 meter, so this is 4,000 plus this will be 2 500, so 500 into V square. Therefore with 500 I can cancel out 5 8 the 40, so V2 square is 9, so V2 will be equal to 3 meter per second. It will come 3 meter per second. So therefore I can say V2 will be equal to 300 centimeter per second. So hence the answer will be 300. And it is told the elastic behavior of a material for linear stress and linear strain is shown in the figure. The energy density for a strain is 5 into 10 power minus 4 is dash kg per meter cube. And it is told that assume that the material is elastic up to the linear strain of 5 into 10 power minus 4. So the energy density that we have to find. So you know that energy stored in the string, that is energy stored, that is equal to half of kx square, that is equal to half y a by l into delta l square, so which is, let's say, half into Young's modulus into delta l by l whole square into the volume. So therefore, the energy density, which is E by L, that is half into Young's modulus into strain square, where strain is delta L by L. change in length by original length. Now here they have shown stress versus strain versus stress graph. Then from here you can find out the Young's modulus. So Young's modulus, stress by strain. So therefore strain by stress, that is equal to 1 by the Young's modulus. So here the slope of this graph, that will give us the value of 1 by Young's modulus by y. So therefore the slope that we can say slope will be this point we can take, which is at stress equal to 80. This strain is 4 into 10 power minus 10, and this point is 0.0 only, or here we can take at 20 when the stress is 20 Newton per meter squared, then the strain is 10 power minus 10. So therefore the slope, which is 1 by 1, that is the slope, which is y2 minus y1 by x2 minus x1, which is 80 minus 20. So it means that 1 by y, that is equal to 3 into 10 power minus 10 divided by 60, which is 3 20 60, and it will be 100 into 10 power minus 12 divided by 20, so 2500. So it is, oh, sorry, so this will be, so Young's modulus y we have to find, so that will be 20 by 10 power minus 10, which is 20 into 10 power minus 10, or I can say 2 into 10 power minus 9 Newton per meter square. So therefore, when the strain is 5 into 10 power 4, that will, then the energy density we have to find in the uh, unit kilojoule per meter cube. Therefore, now the energy density, which is in by air, that is half into Young's modulus into strain square. So that is half into the Young's modulus, it is 2 into 10 power minus 9 into the strain square. Strain is linear strain is 5 into 10 power minus 4. Is 5 into 10 power minus 4 whole square. Sorry, this will be, there is something wrong here. This will be 20 into 10 power 10. So this will be 2 into 10 power 11. 2 into 10 power 11. 2 into 10 power 11 Newton per meter squared. And strain is 5 into 10 power minus 4. So if you take the square of this, so then this will be half 2 and 2 will cancel. So it is 5 5 25 into 10 power minus 8 plus 11. So it is 25 into 10 power 3 joule per meter cube. Or I can say it is 25 kilojoule per meter cube. So the answer will be 25. Then here it is told the elongation of a wire on the surface of the Earth. Elongation of the wire, that is the delta, that is 10 power minus 4 meter. The same wire of same dimensions, that will be elongated uh, by 6 into 10 power minus 5 meter on another planet. The acceleration due to gravity on that planet will be g dash will be how much? Now we know that when we place a wire, then its weight mg will act downwards. So there will be an extension or an elongation in the where so f we know that is equal to ya by L into delta L. So delta L will be equal to FL by AY. So therefore delta L, which is the extension in this case, here the load applied is mg. Mg into L. Same wire of same dimensions. It means the area of cross section and the length will be the same. Same wire of same dimensions. It means the Young's modulus also will be same only since the material also is same. So therefore this will be mg into L by A into Y. And similarly on another planet, the extension that is delta L dash that will be equal to m into g dash into L by A Y. So if we divide these two, then we get delta L by delta L dash that is equal to G by G dash. Since ML by AY is same, so they will get cancelled. So the acceleration due to gravity on the other planet, this we have to find out. Now delta L is 10 power minus 4 by delta L dash is 6 into 10 power minus 5 is equal to G. But we know take acceleration due to gravity on the surface of Earth is 10. So G is 10 meter per second squared by G dash. So therefore G dash that will be equal to 10 into 6 into 10 power minus 5 divided by 10 power minus 4. So this will be equal to 10 power 4 into 10, that is 10 power 5 into 10 power minus 5 into 6, so that is equal to 6. So it will be 6 meter per second square is the required acceleration due to gravity on that planet. So 6 is the answer. And here it is told an ideal fluid of density 800 kg per meter cube flows smoothly through a bent pipe as shown in the figure that tapers in cross-sectional area from A to A2, A to A by 2. An ideal fluid is there which is having density 800 kg per meter cube. It smoothly flows through a bent pipe that tapers in cross-sectional area from A to A by 2. The so here this I can say the area A1 that is equal to A and the area of cross section here A2 that is equal to A by 2. Then the pressure difference and here the speed of the flow is V1 and here the speed of the flow is V2. The pressure difference in between the wide and the narrow sections means here if the pressure is P1, here the pressure is P2. So then P1 minus P2 that is 4,100 or 4,100 Pascal. Then at the wider section, the velocity of the fluid is root x by 6 meter per second or x equal to how much? So the value of x you have to find out and given that g value, given that g is 10 meter per second square, is 10 meter per second square. So x will be how? So here we can apply the equation of continuity, which is a1 equal to a2 b2, which is the equation of continuity. Since the volume flow rate will be same at every point, therefore a1 is a v1, that is equal to a by 2 v2. So a will cancel, so v2 will be equal to twice of v1. So here the velocity will be twice of this. So therefore now we can say p1 plus half rho v1 square plus rho gh1, that is equal to p2 plus half rho v2 square, that is equal to p2 plus half rho v2 square plus rho gh2, which is according to the Bernoulli's principle. So it is the Bernoulli's equation, we can say. Now the pressure difference means P1 minus P2, that is given as 4100 Pascal. Therefore, you can say now P1 minus P2 plus half rho into G1 square P1 minus P2 plus half rho V1 square minus half rho V2 square plus rho G into H1 minus H2, that is equal to 0. So P1 minus P2 is 4100 plus half into rho, that is density of the fluid, that is 800 into V1 square, V1 so 700 V1 square minus V2 square, V2 is 2 V1, so it will be 4 V1 square. At the wider section, this V1 only we have to find out actually. So plus rho G 800 into G, that is 10 into H1 minus H2. So this height H1, the height at the wider section minus the height at the narrow section, that is 1 meter only. So that is 1, that is equal to 0. Now we can divide by 100 on both sides. It cancels. So the 2 4 is 8. So this will be 41 plus 4 into, this will be minus 3 V1 square, then plus 80, that is equal to 0. So therefore I can say 121, that is equal to, what's that, 12 into V1 square. Therefore V1, that would be equal to V1 square, that is equal to 121 by 12. 1 by 12. So therefore, the wider section so we need 6 here, so we can multiply with 3 on both sides. So then V1 square I will get 1 3 3 6 by 36. 363 by 36. So V1 will be root over 363 by 6, which is given as root x by 6. So therefore the value of x will be 363. So this much meter per second. Therefore, the velocity of the fluid is root x by 6, so x will be 363. the velocity of the upper layer of water in a river is 36 kilometers per hour. Velocity of the upper here the velocity of the upper layer of water is 36 kilometers per hour, which means V1 I can say. So that is 36 into 5 by 18. 5 into the 36, so 10 meter per second. So the velocity of the upper layer is 10 meter per second. The shearing stress between horizontal layers, the shearing stress means F by A between horizontal layers of water is 10 power minus 3 Newton per meter square. It's the force per unit area of the surface area of the layers. So then the depth of the river is the depth of the river that we have to find, that is D. A quotient of viscosity eta of the water, that is 10 power minus 2 Pascal second, or I can say 10 power minus 2 Newton second per meter square. Now we know that the viscous force that is given as minus eta A into delta V by delta X, which is called the Newton's law of viscosity. So therefore, eta I can say, which is the viscous viscous by A by delta V by delta X. It is called as the shearing stress by strain rate. Shearing stress by strain rate. Strain rate, it means the, or I can say it is the velocity gradient, which is the difference in the velocity by the separation in between the layers. So therefore, I can say eta, that is equal to the shearing stress, that is 10 power minus 3 divided by this is V1, and the lowermost layer, the velocity, that will be 0 only. So therefore, delta V I can say 10 minus 0, that is 10 meter per second divided by the separation in between the upper layer and the lowermost layer of the river. So that is D. So this D only we have to find out, which is the depth of the river. So therefore 10 by T of this will come D into 10 power minus 4. D into 10 power minus 4 is equal to eta. So therefore D will be equal to eta into 10 power 4. So now eta is 10 power minus 2 into 10 power 4. So that is 100 in meters. So 100 meter is the depth of the river. So 100 is the answer. And here it is told 4 identical hollow cylindrical columns, 4 identical hollow cylindrical columns of mild steel support a big structure. Okay, they support a big structure of mass 50 to 10 power 3 kg. The inner and outer radii of each column, inner and the outer radii. So it is a hollow cylindrical column. It is somewhat like this, hollow cylinder. So the inner radius R and the outer radius R. The inner radius is 50 centimeter and the outer radius is 100 centimeter. So the inner radius I can say 0.5 meter. The outer radius is 1 meter. Then assuming uniform local distribution, calculate the compression strain of each column. So the compression strain, that is minus delta L by L, that value we have to find for each column if we have to assume that there is uniform local distribution of the load. If there is uniform distribution of the load, uniform distribution of the load. So hence it means 1/4 of the weight will be the compressive stress on steel so, uh, each steel support. So therefore the load that is air, that is equal to mg by 4, is 50 into 10 power 3 divided by 4 k means into 10 Newton. G we have to take 9.8 utility store. So m into g, that is 9 into 9.8, this much Newton. Now and the Young's modulus of steel, that is given as 2 into 10 power 11 Pascal. Now therefore calculate the compression strain of each column. So compression strain, that is equal to, know that stress by strain, that is equal to Young's modulus. So strain, that will be equal to sigma by y, which is stress by Young's modulus. So stress will be F by A. Now here the area of cross section that we have to take, which is pi into r square minus r square, since it is a hollow cylinder. So this will be divided by y. So therefore the compressive strain of each column epsilon, that is minus delta L by L. So that will be F by AY, F by AY. So which will be F, that is 50 into 10 power is mg by 4, 10 power 3 into 9.8 by 4 into area, that is pi. Pi is 22 by 7 into r square minus r square, which is r square minus r square. So 1 square minus 0.5 whole square. That will be pi into 1 square minus 0.5 whole square into y. Y, that is 2 into 10 power 11 into 10 power 11. So this much, this value we have to find out. So this will go out. So 50 into 9.8 into 7 divided by 4 into 22 into 2 into this will be 1 minus 0.25, that is 0.75, into this will be 10 power 3 into 10 power minus 11. 7 by 4 into 22 into 2. 75. This will be 4.8 plus 4 is 8, 2 9 is 18. So then this will be this will be 25 3s are 75, 25 2s are 50, 2 11s are 22. This will be so be 490 into 7 by 44 into 3 with 10 power minus 8. So this will be approximately this is 490 into 7. That is 3430 divided by 4 is 12 equal 132. So that is into 10 power minus 8. So this is approximately 26 into 10 power minus 8. Or I can say approx, which is 2.6 into 10 power minus 7. That means that option B is the correct answer. So hope all of you understood the solutions of all these questions based on the previous year JEE Mains exam on the chapter properties of matter. Still any doubts if you have, please write that in the comments. We shall obviously clarify them in the subsequent videos. And also in any other chapter of physics, if you have more difficulty, then please mention the name of that chapter also, so that we shall give more priority on it and solve more and more questions on that chapter. Also, please install our Sapience education application, where we have uploaded some important questions which shall be obviously helpful for your JEE Mains exam. The link of the Sapience education application has been provided in the description. So please install it. It shall be helpful for you. So thank you everyone. Bye.